Imagine logging into your dashboard to check your metrics, but instead of your analytics, you're staring at a major competitor's private, unreleased data. In the world of shared cloud architecture, this is the ultimate nightmare, a total failure of the multi-tenant model. Take a look at this Nimbica dashboard. It's managing traffic and tracking deployments for dozens of domains from a single hub. This architecture exists for efficiency. Thousands of clients share the same global edge network to achieve massive page speeds at scale. But that shared power introduces a structural tension. Client A's data and Client B's data aren't kept on separate physical servers. They sit right next to each other, separated only by invisible walls made entirely of software. Because software is written by humans, it will always have bugs. No matter how fast or scalable a platform is, those metrics become meaningless if those invisible software walls ever come down. To understand this risk, let's look at how data moves through the back end. When a user updates their site, their raw content enters a shared pipeline, rapidly processed and optimized right alongside data from entirely different users. This shared rendering phase is the window of vulnerability. All it takes is one microscopic error, a memory cache failing to clear in time, or a tiny routing ID swapping lines in the code. If that happens, the system accidentally stitches Client A's private data straight into Client B's pre-rendered HTML file. Modern platforms deploy new code constantly, sometimes multiple times a day. Relying on human engineers to manually catch these microscopic routing errors before they go live is an impossible task. A system that rapidly changes its own code cannot rely on human vigilance. It has to be designed with the explicit expectation that it will eventually fail. The real engineering discipline keeping these walls intact is a daily gauntlet, an automated adversarial testing pipeline. Instead of hoping the code works, the platform attacks itself. Automated test scripts act as malicious actors, aggressively trying to query one client's data using another's credentials. They then multiply to overwhelm the queue, attempting to force a cross-tenant leak. The system has absolute zero tolerance. If even a single adversarial test succeeds in accessing someone else's data, the entire build is instantly failed. A fatal error is thrown, and the alarms go off. Flawed code is physically blocked from ever touching the live network, simply because it couldn't survive a deliberate, self-inflicted attack. This invisible war plays out multiple times every day, triggering automatically with every platform update. Looking at this plugin dashboard, you can see the end result. Thousands of pages safely and successfully deployed across hundreds of global edge locations. This relentless background testing is exactly what allows users to confidently leverage massive shared infrastructure. Clients get the immense speed required to handle sudden traffic spikes and rank high in search engines, entirely without the vulnerability of a shared data pool. True platform security requires operating on the core assumption that bugs will inevitably happen. Trust in this architecture is a relentless, automated discipline, engineered entirely to catch catastrophic failures in the dark, long before a customer ever sees them.